This is 6.4, slope-intercept form of a linear function. Recall that last chapter we learned to describe a linear function in different ways. The number 0.20 is the rate of change, or the slope of the graph. The number 60 is the vertical intercept, or the y-intercept of the graph. In general, any linear function can be described in slope-intercept form. This may or may not slowly become your favorite form. M is the slope, B is the y-intercept. So if we want to write the function given the slope and its y-intercept, and we are looking at y is equal to mx plus b, y is equal to the slope minus the y-intercept. And it's minus in this case because the y-intercept is negative. Graphing a linear in slope-intercept form. So when we are graphing a slope-intercept form, I'm going to write out some steps for you here, and we're going to follow those. So the first step should be identify the y-intercept. So our y-intercept in y is equal to 1/2 x plus 3 is right here. Okay? So we're going to plot that. So once that's plotted, your second step is to use the slope to plot 1 to 2 points. So our slope in this case is 1/2, so that means up 1 over 2. We could also do the negative version of it. So this is down 1, left 2. This means the same thing. So if we went up 1 and over 2, so up 1 over 2, we get a point right here. And then if we went down 1 and over 2, we get a point on either side of the axes here. And you could do that to the edges of the graph if you really wanted, but it's not necessary. So our last step is to connect the dots here with a straight line. So this, because it's a function, it needs to extend to all parts of the graph. So then this should be, I think, about right here. So it either needs to extend to the very edges of the graph, or you need to add arrows to it to show that it is a continuous line. Okay, and then we're going to go on to the next one. Write the equation given the graph. So we are going to find the y-intercept and the slope. So the y-intercept is equal to -4. And then we are going to count out the slope from -4. From -4, we go to, let's say, here. That feels like a good point, from here to here. So then 1, 2, and then 1, 2, 3. So that should give us m is equal to down 3 over 2. So that means our equation is y is equal to -3 over 2x minus 4. Okay, this one, our y-intercept is equal to -3, and our m, let's use that pen again. We start here, and our next viable point looks about there. So then 1, 2, 1, 2, 3, 4, and it's positive because it's increasing going to the left. So I said that was up 4 over 2. That's going to disappear right away. Up 4 over 2, and we should always reduce this. So that should give us up 4, 1, 2, 1, 2, 3, 4. Yeah, so that should give us 2 over 1. And then in our equation, it's just going to be 2x minus 3. Okay. Use the equation to solve a problem. The student council sponsored a dance. A ticket cost $5, and the cost for the DJ was $300. So this is a base one that we have to have. So the price depends on the sale of tickets, is equal to $5 per ticket minus the original cost of $300. Suppose 123 people bought tickets, so P at 123 is equal to 5 multiplied by 123 minus 300 is equal to 615 minus 300 is equal to 315. Suppose the profit was 350. How many people bought the tickets? 5t minus 300. Add 300. 650 is equal to 5t. So that leaves us with 130 people bought tickets. Could the profit be exactly $146? Justify the answer. Okay, so let's take that and let's plug it in. So if this was 146 is equal to 5t minus 300, we add 300 over and we get 446 is equal to 5t, and we divide by 5. We get 89.2 is equal to the tickets. So no, because the tickets cannot be kind of sliced. You need to have one whole ticket.